I got negative 140.
All right, so we've been working on the warm-up for about 5 minutes. You have a couple more minutes left. For those of you that just joined us live, copy the warm-up. It's warm-up number 74, and it's posted, numbers 1 through 4. Got a couple more minutes. Just write it down. You can do that at home by yourself once we continue with the lesson. And by the way, those of you that are joining us live, we're on a delay for about maybe 3 seconds, 3 to 5 seconds delay.
You're live streaming right now.
I'm live streaming for those that are absent. They were not feeling well.
So Gio's watching. Hi, Gio. I got 2 negative 1. 2 negative 1. Over number.
Okay, hands up if you need more time. Okay, 1 more minute. 1 more minute.
Do you want us to check number 3?
For right now, that's fine.
Okay.
Okay.
Yeah. So 2 adjacent angles. I thought adjacent were right next to each other. Or were they like same size? Or were they just parallel? So is it parallel? Yeah, it would be like right next to each other. Is it X, and no. Yeah, last one. Is N on the Y is 3?
Caleb?
Double check out this one.
You're welcome. All right, here we go. Number 1. Also, by the way, when I'm live on your stream, you're not going to be able to see my pen as it writes, but you're going to see the writing as it comes up on the screen. So don't think that I'm not writing. It is. Like right now, everybody that's in class, you guys see the pen, right?
No.
Oh, I have it frozen. My bad. You guys see the pen, right? Okay. All right, here we go. Number 1. I'm going to go over these just to make sure I'm refreshing your memory. To solve this one, I subtract 9 from each side, and I'm left with negative 4 less than t. Hands if you got that. Okay, good. Let's graph that. 0, negative 4. Does this have an equal sign? No, so it's an open point. Some of you missed it on the final. Some of you kept missing the filling the point and not filling the point. So tell your neighbor what this means if we don't fill the point. If we don't fill the point.
It can't be negative 4. It can't be that number.
Very good. It excludes negative 4 from the solution, right? So therefore, in order to, for those of you that forgot how to graph, here it goes, because I was getting that from other classes. If you forgot how to graph, let's check, and that's going to tell us how to graph or which direction. So watch. To check, I need to substitute a value for t. I can either substitute a value on the left side, which is the very next number is negative 5, or a value from the right side. So either side I can substitute a number. Which number would you like me to substitute? Negative 5 or something from over here?
Something from over there.
All right, I'm going to substitute 23.
Yeah. Okay.
So instead of t, I'm going to write 23. I'm going to bring everything else down. Negative 4. Is negative 4 less than 23?
Yeah.
Yes, if it did work, that means that this point is in the solution section, so all this is a solution to the inequality. If it wouldn't have worked, that means I would have shaded the opposite direction, okay? And of course, you guys know that you should write your solution set.
I'm sorry.
Solution set of t such that t greater than negative 4. Hands if you got that by yourself. Okay, good. Let's go to number 2. Here it goes. For number 2, distribute, we get 6z plus 2 equals negative 2z minus 6. From there, plus 2z plus 2z, we get 8z plus 2 equals negative 6. So far so good? Minus 2 minus 2, 8z equals negative 8. And my last step, divide by 8, z equals negative 1. Hands if you got that. So far so good. Next part, properties. So here, what did I do in red? Distributive property. What did I do next? Addition property of equality. What did I do next? Subtraction property of equality. I'm bringing these back, hint, hint, just in case on the next parte they ask you for this. And what is the last part? Division property of equality.
This is basically a teacher.
Yeah, it's the 2-column proof. Yes, we're gonna get it. Oh, thank you. We're gonna get into window notes. Everybody say thank you, Lily. Yay! Be nice. All right, so that was 1 and 2. Let's go to number 3. Show of hands. Who used the graphing method to solve that system?
Nope.
How about substitution? Who used elimination?
Nope.
Okay, so I'm going to use elimination for this one. Here it goes. So which one eliminates? The y's, yes? So what is 3x plus 1x? That's 4x. 10 minus 2, that's 8. Divide by 4. X equals 2. I'm going to get one of the 2 equations to substitute that value. I'm going to take the bottom one. X plus 4y equals negative 2. But instead of x, I'm going to write 2. Bring everything else down. 4y equals negative 2. Minus 2 minus 2. 4y equals negative 4. Divide by 4. Y equals negative 1. Solution 2, negative 1. Hands if you got that. Very good. So, and the last one, number 4. When talking about geometry, you're going to see in your first chapters when you get to the high school that they're going to be talking about a lot of angles. So I'm trying to get you as much through the first chapter of geometry by the end of the year as possible. Here goes the next concept, adjacent angles. You should have already seen these before, but if not, let's see, here it goes. What are adjacent angles? Adjacent, by the way, the word means next to. Is that correct? So in reference to angles are angles next to each other and share one side. Angles next to each other, but they share one side. Now, for those of you, once again, that this is something new, if you notice, all these angles here have something in common, the letter Q. The letter Q is known as the vertex because that's the beginning of the angles, or that's what makes the angle. So let me show you the different angles here. The first angle here that I'm going to sketch is XQY. Let me show you another angle. Angle YQZ. Next one. Bless you. Angle ZQP. So far so good. And angle PQX. Do you guys notice that?
Yeah.
Now there's more. I can make more combinations, but for right now, for the purpose of this, I'm going to stick to those. Are we there? So check this out. I'm going to write you 2 adjacent angles. I'm going to start with this one. And this is the symbol for angles. Angle XQY. First of all, who notices that the vertex is in the center of the 2 other labels? You guys notice that? So XQY, all right? That one is adjacent to angle YQZ. Do you agree with that? this angle is adjacent to this one. Are they next to each other?
Yeah.
Are they sharing one side?
Yeah.
Yes. So with that said, if I gave you the angle YQZ, give me another angle adjacent to that one. Not the one I have here. Give me another one adjacent to that one and share it with your neighbor, please.
Don't think out loud. CQP. Jeez, guys. I gave away the answer.
Let's see. Emily, what angle is adjacent to angle YQZ? Angle ZQP. Hands if you agree with that. All right. And let's do one more just for the sake of it. Which angle is adjacent to angle ZQP? Tell your neighbor, please. Whisper to your neighbor.
Thank you, Mr. Q.
You're welcome. Yeah. Jeremiah. Angle. Well, yeah, because we already have it here, but I said what other? Lily.
Oh, PQX.
PQX. Hands if you agree with that. That is correct. This one and this one are next to each other, and they have one side to share. Yeah.
So let's ask if we forget to put the angle sign, we mark it.
We don't have tests.
A parte.
For the parte. The question was for a parte, if we forget to put the angle, will I mark it wrong? No, I'll just take a point off.
Oh, okay. Got it.
Yes, Jocelyn.
Does it matter whether like YQZ? Whether we say YQZ?
YQZ or ZQY? No, that's fine. As long as you leave the vertex in the center of both. Did everyone understand? Yes.
So what happens if the vertex isn't?
If the vertex isn't in the middle, then not only I would dock a point, that would be completely wrong.
No, but then how would it look like?
Oh, how would it look like? Some people would write X, Y, Q.
Like, how would it look like in form of like
It's a
an
different
angle?
But it's a different angle then.
Yeah. So then, like,
What do you mean?
Fixing up.
I'm just saying, like,
If Q wasn't in the center, then you cannot make an angle because you need this one to make all the angles. Okay? All right, get a blank sheet of paper out, please. For Cornell notes, we're still on the same standards in regards to systems pertaining to precision. Except for today, we're already applying systems. So title your notes, Applying Systems. And our objective for today, I can solve real-world problems using systems of linear equations. Let's read together. 1, 2, 3. I can solve real-world problems using systems of linear equations. Tell you the concept we're still on, please.
systems of linear equations.
So get a Fermi model going, please, for systems of linear equations. I'm sorry? Oh, let's see if it's true. Thank you, Caleb. Everybody, thank you, Caleb.
Thank you, Caleb.
So without looking at your notes, I want you to fill in your Fermi model for definition, one example, one unexample, and hashtags for systems of linear equations.
Okay, Mr. Gavin, still making your model.
Okay.
I haven't even written that.
And BTW, FYI, I'm not going to play background music because what happens is that because of copyrights, they flag it, and I don't want them to flag the video, so I can leave it on for anyone that needs to view it later.
You're still making videos?
I'm sorry?
Yeah. Can you
Wow. Yeah, because what it does, as I'm live streaming, it saves it as a video. So, bam. Okay.
Wait.
Oh, I have it right there.
So, let's see how you did with the definition. Definition for system of linear equations. It should say the set of two or more linear equations that have the same variable. Hands if you got that.
I'm still
Good.
writing down that question.
Oh, wow.
Me too.
The only thing I didn't do is a set.
Okay, not bad. Give me an example, a non-example, and 2 hashtags. Hurry up, please. And loosen up your wrist. Today we're going to do like some writing. Writing, since we're going to be looking at word problems. Yay!
I write off my that keeps a bit off my pencil.
Okay.
I just entirely skipped
I didn't even write the song.
Mr. Fielder.
Yes.
For the sake of time, I'm just gonna put a set of 2 plus.
Okay.
Plus.
Let's see. Example, non-example. See if it looks like this.
Totally does.
Something?
Yeah, sure.
Yeah? Be nice.
It's like, ooh.
With those answers like, yeah, sure. My goodness.
No
What if
comment.
that's just how we are? Are you trying to tell us to change Mr. Q? Be nice.
Yes, I'm asking you to be nice. Bam.
I don't know how to do that so far.
Alright, so
Damn, that's cool.
pretty much we know that right after our FAIR model, I usually give you steps. Is that correct?
Yes. But you're
But-
not gonna do that this time.
But you already know the steps to solving systems by graphing, substitution, or elimination. Is that correct?
Yes.
The only thing I want to revisit for today's lesson is that since now we're doing applying systems to real world problems, and the reason I'm moving on, you already have the FAIR model. Is that correct?
No.
You already should have that in your notebook.
What notebook?
Anyways, here we go. So think about it. We've been using already, since I introduced word problems with equations and inequalities, we've already been using a problem solving strategy. Tell your neighbor, which problem solving strategy have we been using? Yes? Alright. That is correct. Step 1, circle important numbers. Step 2, underline the question. Step 3, box the important terms or ideas. Step 4, exclude unnecessary information. Step 5, draw pictures, diagrams, tables, etc. And this is known as what? Cubed. Yeah, we've been using that every time we dissect a word problem. Is that correct? The only difference is that if you want to write that down, that's fine. You should already have this in your notes.
Yeah.
But if you don't, every time that you come up and get an iPad for the lesson, when we do Nearpod or whatever, it's over there in the poster, right? You guys stop and read the posters and stuff? All right, good.
They're pretty.
All right, thank you. So our acronym is CUBED. So for the purpose of today, we're going to use this acronym. So write this example down. Like I said, you don't have to write this down because you already have it, right? All right, here it goes. Example 1. It says, Sonia has $7.75 to buy 12 sheets of felt and cardstock for her scrapbook. Yeah. Yeah. And by the way, we have a new pass. Bam. Check this out.
Whoa, it's an actual pass. And not a post-it
Bam.
note.
Bling, bling. And by the way, check this out.
May the 4th.
There you go.
Yeah, because it's like Merry Christmas.
It says, Merry
Yeah, say Merry Christmas.
Merry Force be with you. Bam.
Is it definitely Christmas?
It says Sonia has $7.75 to buy 12 sheets of felt and cardstock for her scrapbook. The felt costs 50 cents per sheet and the cardstock costs 75 cents per sheet. How many sheets of each can Sonia buy? Copy that, please. Everybody ready?
No.
Come on, tomatoes. Once again, it says example 1. Sonia has $7.75 to buy 12 sheets of felt and cardstock for her scrapbook. The felt costs 50 cents per sheet and the cardstock costs 75 cents per sheet. How many sheets of each can Sonia buy? The material felt, everybody knows what it looks like. I just showed you the pass right now. It's kind of like very flexible, looks kind of spongy, and that's felt. Cardstock is, if you remember when you came into Frank Wright in 6th grade, remember your first ID that you got with your picture, that they actually laminated it?
Yeah.
That card was made out of cardstock, yes.
Or like the paper that we get our locker combination.
There you go. Or the paper that you get the locker combinations on. That's cardstock. It's a little bit thicker than construction paper. Okay? So here we go. So, let's get started by cubing this problem. Cubed. I'm going to use blue to circle important numbers. Important numbers is that Sonia has $7.75. She's going to buy, what, 12 sheets. Important number is that felt cost 50 cents. And cardstock cost 75 cents. Okay? U for underline. Let's underline the question that they want us to answer. How many sheets of each can Sonia buy? I'm going to switch to green. Box key information. Key information here is that we're talking about 12 sheets. Okay, so sheets, that's important, but sheets of what? Felt and cardstock. All right. With that, we're going to exclude any other information that we don't need, all that extra fluff. But we do need to draw a table or diagram or so. So from this point forward, guys, when we're talking about systems of equation, we're going to do a table very similar to the one we used to make. So check this out. This is a table we're going to use. 3 lines down, 1, 2, 3. But instead of 1 line across, we're going to draw 2 lines across. Because how many equations do we need to come up with? 2. Okay? And we always put the total at the top right. Is that correct?
Yeah.
Total on the last one. So watch. Let me show you how easy it is to start filling in this table by labeling it. Here we go. First of all, what items are we talking about here in this problem?
Cardstock and felt.
Felt and card. Which is the first one that they mentioned? Felt. So I'm going to write it in the first column. Felt right here. Felt. And the next column is what? Cardstock. Cardstock. Okay. Now, if you notice, this problem's a little different from the ones we've done in the past. They're talking about items, but what else are they talking about in this problem? Yeah.
Unit rate?
Well, the rate, unit rate, but what are they talking about in regards to unit rate? They're talking about money. Yeah, unit rate involving money, yes? So check this out. This kind of problem is known as a item and cost kind of problem. So whenever you approach these problems, they're known as item and cost. So for that purpose, I'm going to label this first row, I'm going to label it items. So, what items did we talk about? Do we know how many felt sheets she's going to buy?
Yes.
We do?
No.
No. If we don't know, what can we label this? X. Do we know how many cardstock?
No, so it's Y.
Y. Do we know how many total sheets she's going to buy?
Yes.
How many?
12.
12, and that goes right there. Now, for the sake of keeping it organized, felt corresponds to the X and cardstock corresponds to the Y, because at the end we need to answer a question. We need to make sure that we know what we're talking about here. So that was that row. The next row, since this is an item cost, what am I going to write here?
Cost.
Cost. What is the cost per felt? So it's 0.50. Since we don't know how many, it's 0.50
X.
X. Therefore, the next one would be what? 0.75y. And what is the total amount she's going to spend? 7.75. Do you see the system now?
Yes.
Yes, let's write it underneath. I'm going to use the same colors. X plus y equals 12. And the other is 0.50x plus 0.75y equals 7.75. So far, so good? Yeah. So now check this out. This is where it gets interesting. We have a system, don't we?
Yeah.
And we have how many methods to solve the system?
3.
3. Which method would you use? Tell your neighbor, please.
Substitution.
Eliminate just takes too long.
Thank you.
Too much time.
Hands if you would use graphing. Hands if you would use substitution. Hands if you would use elimination. Okay? I'm going to use elimination. Check this out. You're like, what? Yeah. Let me ask you this. If I was to eliminate one of the variables, let's see, Gloria, which one do you want to eliminate? If we were to eliminate one of the variables. Y. Okay? So if we wanted to eliminate y, tell your neighbor what we need to do to that equation, please.
Times it by, or multiply by negative 0.75.
Did everybody hear that?
No.
Yes, multiply times 0.75. Distribute negative 0.75x. Distribute negative 0.75y equals to negative 9. Thank you. Okay. Everybody following along, right? All right. So now we have these two equations. Can we eliminate now?
Yes.
Yes. So which one are we going to eliminate? The y. Everybody say thank you, Gloria.
Thank you.
Yeah.
Why is it negative 0.75?
Right here. Because we distributed it here.
I meant that one. Why is it?
Oh. If we wanted to eliminate, look up please. Question was, why do we need to multiply times negative 0.75? In order to cancel the two y's, they need to be opposite coefficients. Is that correct? And if this one's already positive, then we need one that is what? Negative. So that's why we multiply times that. All right. So therefore, 0.50x minus 0.75x, we're left with negative 0.25x equals 7.75 minus 9, that is negative
1.25.
1.25. Let's solve. Divide by negative 0.25, both sides. X equals 1.25. Let me show this because some of you are still kind of like making mistakes with decimals, so hopefully you remember to get rid of decimals. No longer decimals. So 25 into that is 5 times. 125 is 0. That's 5. And the 5 corresponds to what? Felt. Yes, Lily.
If this is going to be on a part A, do you need to show the long division?
Bam!
It's work, but like it's simple work.
I know it's simple work. However, this is where some of you make mistakes in your noodle. So I'd rather you guys write it out. Yeah.
What if we draw it like instead of 25 because it's quarter? Can't we just draw quarters instead and do that?
That's fine.
Okay.
Yeah. So let me ask you this. Look up, please. From the original two equations, which equation should we use in order to find the other item? I know, which equation shall we use to find the other item?
X plus y equals 12?
X plus y equals 12, because that's the what? The item equation. But now we know that x is what? 5. Bring down the plus y equals 12. Minus 5. Y equals 7. And 7 corresponds to
Card stuff.
card stock. So now since we have to answer the question, what is the question? How many sheets of each can Sonia buy? So let's write our statement. Sonia can buy 7 card stock sheets and 5 felt sheets with, how much does she have?
$7.75.
$7.75. 10Q. Look at it. What a beauty. Yes?
Yes.
Okay.
Not so beautiful.
So, we know what to do from this point forward, right? When we get a system. What we need to start figuring out is how to organize our information. You know what I'm saying? So, I'm going to let you know, in a partay, this problem, only one of these is worth 5 points. Why? Because we want to see some sort of organization. We want to see an equation. We want to see a solution from one variable, solution to a second variable, and a statement. Everybody with me? All right? Yes?
We extra points from the 10Q.
Bam! No. Yeah.
So if we don't do the table, you mark off the point?
If we don't what?
If we don't do the table, we can get marked off the point.
1 point. Yeah. Yes?
Have, have we learned this sort of thing before using the different variables and such, but using a different method?
Yes.
To solve it?
Yeah.
What was that?
Yeah, it looks similar because before, instead of coming up with one equation, we came up with 2 equations. And when we were in multi-step equations, they were just one equal to the other. So it looks kind of similar. All right, let's do another one. Yeah.
What other ways could you make a table? Is that like the easiest way?
I think this is the easiest way for this process. Here you go. Copy this, please. Yeah.
Can you do the same using substitution?
Yeah, you could have used substitution. But right now, I just wanted to show elimination because it's probably like the most one that's going to be, or the most simple to use. Yes.
The party, do we have to do the cube steps?
No, as long as I see some organization like this. Here we go. Copy this one. Example 2. It says Chris spent $14.85 to buy 13 flowers. He bought lilies, which cost $1.25 each, and tulips, which cost 90 cents each. How many of each flower did Chris buy? Chris spent $14.85 to buy 13 flowers. He bought lilies, which cost $1.25 each, and tulips, which cost 90 cents each. How many of each flower did Chris buy? For this one, I'm going to give you a head start. See if you can cube it by yourself. Get a table going, label everything correctly, and write your system and see if you can go from there. Okay? For those of you watching online, we have one more different example to go with. If you want to go ahead, I already uploaded the video for the previous lesson. It's already up there, so you can go to the where my videos are at on the channel, and then just watch the last part if you want to go ahead. Okay. All right. So let's see. I gave you a head start. I'm going to cube this. Circle important numbers. Spent 1485, 13 flowers. Lilies cost 125 each. Tulips cost 90 cents each. Okay. Underline the question. How many of each flower did Chris buy? Box key information. Key information here is that we're talking about what? Flowers. What kind of flowers? Lilies and tulips. Exclude any other information that you don't need. Let's draw my table. 1, 2, 3, 1 across, and 2 across. This is the night and type of problem, so total right here. What are the items? We got lilies. I'm going to label that X. Tulips. I'm going to label that Y. And I'm going to start with the first row, which is items. What items? X, Y, and the total number of flowers, 13. Second row is cost. What is the cost? It's 1.25x and 0.90y, and the total amount being spent is 14.85. Hands if you got that. Okay, good. So my system should look like x plus y equals 13. And then we got 1.25x plus 0.90y equals 1485. And from there, I'm going to eliminate Jocelyn. You want substitution? So which one do you want to solve for, x or y? Okay, so then we subtract x, so we get y equals negative x plus 13. So instead of y, I'm going to write negative x plus 13. Bring everything else down. 1.25x plus 90 times that equals to 14.85. So I'm solving this one using substitution for as a request here in class. So 1.25x plus negative 0.90x plus, let's see, 13 times 0.90, 0, 7, 2, that's 11, 2, that's 11.70 equals 1485. Yes, Caleb?
Oh, just did you dot?
Oh, yeah, right there. Come on, like terms. This is 0.35x plus 1170 equals 1485. Subtract 1170. 0.35x equals, is it 3.15?
Yeah.
Divide by 0.35, x equals 9. Yes?
Yes.
And that corresponds to lilies. Hey, lilies.
I'm not for sale.
And which equation is for the items? X plus y equals 13. Oh, my goodness. X plus y equals 13. And instead of x, we're going to write 9 plus y equals 13 minus 9 minus 9, y equals 4, and that corresponds to tulips. And your sentence will be, Chris bought 4 tulips and 9 lilies with 1485 10Q.
That was too fast.
Hands if you got that. Good, good.
What did I get wrong?
Yeah, that's why I don't know if you're starting to notice that if you do substitution, there's more possibilities of making a mistake. Is that correct? So what was a little bit simpler to do? Elimination.
Yeah.
Everybody say thank you, Jocelyn. Yes.
Thank you, Mr. Q.
On
You
the
do all
next
this work for
party, will we have problems where we have to do substitution?
Damn. No, I'm gonna give you the option of doing whatever you want.
What?
Mr. Q, this is actually handy, this the elimination
Oh,
thingy,
I
and I
think
thought it was
substitution will make
useless.
sure.
Yes. All right, here we go. I'm gonna go up. Yes.
So if of the graphic one.
Yes. At that point, once you have your system, you have how many methods to use to solve?
3.
You could use whatever method. I'm going to give you the option of using any method. That's the purpose of you learning all these methods, to use the easiest one. Okay? Here we go. Look at this next one. Example 3. With a tailwind, an airplane makes 900-mile trip in 2.25 hours. On the return trip, the plane flies against the wind and makes the trip in 3 hours. What is the plane speed? What is the wind speed? As you're copying that, follow along. I'm going to go a bit faster on this one. Notice that this one is a little bit different from the rest. Yes? Yes, Mr. Q.
Yeah.
So if I was to cube this, for right now, I'm going to go straight to building my table. 1, 2, 3, 2 across. This one, does this involve cost? No, some of you are going to miss it. This is very important, so you're distracted. It doesn't involve cost. It involves distance, rate, and time. And this is what we call a rate problem. And let's see if you remember this from your science class. Rate times time equals distance. That is correct. We're going to use that as our labels in our columns instead of writing total. Isn't distance also a total? Yes. For right now, we're going to leave it as that. So watch. If I was to already have cubed it, what is the first thing that they mentioned here? Tailwind. I'm going to write that right here. Tailwind. The question was, what is the plane speed? What is the wind speed? That's why I'm going a little bit faster here. So for variables, I'm going to use P for plane and W for wind. So let me ask you this. The other day that the wind was blowing really hard. If you were to be walking out off campus, from here you started walking, the wind was blowing really hard, and you started running, and the wind was on your back, which means tailwind, right? On your tail. Is that going to increase your running speed or decrease it? Increase. So here we put a plus. And what is it going to increase? The plane and the wind speed. So we're going to P plus W. What is the round trip? I mean the distance? 900 goes here. And what time did it take for that trip? 2.25. All right. Next one. Against the wind. The return trip is against the wind. So I write that here. Against wind. When you're going against the wind, does that increase or decrease your speed? So here we're going to write what? P minus W. That was in 3 hours. And what is the distance? If it's a return trip? 900. And now we have a system. Do you guys see it? Watch. P plus W times 2.25 equals 900. Leave a space underneath that. And then let's write the other one. P minus W times 3 equals 900. But it looks kind of funky right now, doesn't it? I need to get rid of that 2.25. So watch. Divide by 2.25. Divide by 2.25. We're left with P plus W equals, what is 900 divided by 2.25? Very good, 400. Thank you, Caleb. Divide by 3, divide by 3. What do we have left for the second one? P minus W equals 300. Look at this. Does this look familiar? Which method would you like to use on this one, Jocelyn?
Elimination.
elimination, yay! Can we eliminate any of the variables? Yes, the W. We're left with P plus P is 2P equals 4 plus 3, that's 700. Divide by 2. What is the plane speed? 350 miles per hour. Which equation do we want to use? P, the red one or the blue one?
Red.
Red. And instead of P, we write 350.
Equals P, 50.
Subtract 350. Subtract 350. The wind speed is 50 miles per hour, and you write your statement. Yes? Home plate for tonight is page 309 only. There's tutoring today. Have a good one, guys. Enjoy your home play. See you guys tomorrow. Those of you online, thank you. See you guys later. Bye. Hold on.